Welcome to our conference, METASOFT 2022. It's a 3-day conference. Today is the second day. We'll start this. Today we'll start with our keynote talk of Dr. Durga Prasad Mohapatra. So now the talk of Durga Prasad Mohapatra sir will start. Let me give introduction to Dr. Durga Prasad Mohapatra sir. Dr. Durga Prasad Mohapatra sir is the Professor of Computer Science and Engineering Department, NIT Rourkela. Dr. Durga Prasad Mohapatra received his PhD from IIT Kharagpur and is presently serving a professor at NIT Odisha. His research interest includes software engineering, real-time system, discrete mathematics, and distributed computing. He has published more than 100 research papers in this field in various international journals and conference proceedings. He has received several project grants from DST and UGC, Government of India. He received the Young Scientist Award for the year 2006 from Odisha Vigyan Academy. He has also received the Professor K. Arumugam National Award and Maharashtra State National Award for Outstanding Research in Software Engineering. Now, today his topic is test scenario optimization using meta-heuristic algorithms. As our topic is meta-heuristic algorithms in software engineering and its application, basically our the conference is the papers that are accepted. It is divided into 3 tracks. One track is all the meta-heuristic algorithms. Second track is application of meta-heuristic algorithms in software engineering. Third one is machine learning and its application. So this today talk is test scenario optimization using meta-heuristic algorithms. That is the application of meta-heuristic algorithms in software testing for optimization. Basically, meta-heuristic algorithms are used for optimization of test cases, optimization of test suite, generation of test cases, and also for test scenario optimization. Now I request Durga Prasad Mohapatra sir to please start his talk.
Okay. Thank you, Dr. Rai, for your kind word introduction. So actually, I am not a meta-heuristic specialist, but we use these meta-heuristic techniques in various software engineering problems, mainly in the optimization of test cases or in the prioritization of the test cases we use. So today I will just give a small talk on this, how these meta-heuristic techniques can be used in this optimization of the test cases, preferably for object-oriented software. So I will divide my talk actually into 3 parts. First, what is software testing? Then little bit on this regression testing, because regression testing, it can be divided into 3 major categories: test case generation, or you can say test case selection, test case optimization, and test case prioritization. So I want to tell you that where this test case optimization fits in the software testing process. Then, nowadays people are using very few people are going for code-based testing, rather people are migrating towards model-based testing. So how these different UML diagrams, they can be used for generated test cases. So we require a little bit basic knowledge of UML diagrams. Then third part is this meta-heuristic algorithms, how the different meta-heuristic algorithms can be used for optimization of the test cases. So in this way, I have divided my talk into 3 parts. So you can interrupt me at any point of time, because there are some fundamental things I may skip, because as I have already told you, I am not a meta-heuristic specialist. So you also are, I find many of many of you are teachers. Some of are very known faces to me. So I hope you know these basic fundamental concepts: what is software testing, what is regression testing, what is UML diagram, what are the different types of UML diagrams, the fundamentals of meta-heuristic algorithms such as ant colony optimization, particle swarm optimization, cuckoo search algorithm, it's a Firefly algorithm, differential evaluation, and so on. So we also do not have time to cover all those things. We are having only 1 hour time. So with this, I will try to little bit squeeze my talk, but the slides I have put, sufficient number of slides I have put in my lecture. So whenever you will find any difficulty or I'm skipping something, please immediately either raise your hand or unmute and just ask me your doubt, or you can chat box. I'll be happy to answer your queries as far as my knowledge is concerned. So please don't hesitate to ask me any question. Whatever I know, I will just share with you. So this is, if you see many of you are working in also software engineering. So let's start now the talk without wasting the time. I'm sharing my slides now. Let's see. Okay. Just 1 minute. Right. Okay, please let me know whether the slide is visible. Anyone?
Yes, sir.
Yes. Okay. Thank you. So as I have already told you, I have tried to fit my talk to the theme of the conference, as it is based on meta-heuristic algorithms. So I thought I should give a talk on this, how these meta-heuristic algorithms can be applied to software testing. So that's why I have chosen this topic, test scenario optimization using meta-heuristic algorithms. Okay. So with this, let's proceed. So told I will divide my talk into 3 parts: basics of software testing, then little bit basics of the different UML diagrams they can be used for software testing, then the application of meta-heuristic algorithms for software test case optimization. In this one, there are actually so many meta-heuristic algorithms. I will also give you a classification of the different meta-heuristic algorithms. In my work, we have used preferably cuckoo search algorithm to optimize the test scenarios for object-oriented systems. Okay. So this fundamental thing you have already known. We'll just a little bit just refresh your memory that software testing is a process of investigating a system or checking a system or the different components of the system to verify that, to ensure that it satisfies the specified requirements. What requirements you have mentioned in your SRS document, all the requirements are satisfied by your software or not. The process of checking or investigating this aspect we call software testing. There are 2 types of requirements, functional requirements and non-functional requirements. So both the requirements have to be satisfied by the software, not only functional requirements. Non-functional requirements, they are also as equally important as these functional requirements. For example, if you take a library information system, the various functional requirements are issue book, return book, check availability, compute file, etc. Whereas non-functional requirements are what? Like the usability, security aspects, reliability aspects, maintainability aspects. These are all the non-functional requirements. So now, since we are dealing with software testing, we should know a little bit about what is a test case in software testing. So normally, when you are saying test case, it is a triplet ISO, where I is the input data that will be provided to the system. S, under which state you are giving this input I, that is the S, and O, what is the expected output of the system. In this, you define a test case. So what is the objective? We give your test case to a software, observe the output. So whether your expected output is matching with the actual output or not. If it is not matching, then note down the conditions. Under what conditions the output is different. By how much margin the output is different. Check this difference. That then we have to minimize that gap. We have to minimize that difference. So this is what is known as this software testing. Okay. So, but in my talk, I have told software test scenario optimization, not test case optimization. Why? There is a little bit difference between test case scenario and test case. For a layman, it may be exactly same, but actually they are not exactly same. They are a little bit different. Let's see what is the difference between a test case and a test scenario. So whenever we are saying test case, I have already told you, it's a triplet ISO, input and the state in which you are giving the input and the output. But test scenario means it is an abstract test case. Abstract test case means in the sense that it will only identify the aspects of the program that are to be tested. So which aspects you want to test without identifying the input, state, or output. So without looking at the input or the output or the state, what we want to see, we want to identify the particular aspects of the program or the particular aspect of the system that need to be tested. So this we call as a test scenario. In object-oriented systems, you see there are so many methods. So there the meaning of test case little bit different. So normally for object-oriented systems, we define it as a test scenario without speaking, or instead of speaking as a test case. So a test scenario is an abstract test case in the sense that it only identifies the aspects of the program that are to be tested without identifying the input, output, and the state. Now a test case can be set to be an implementation of a test scenario. What is the relation between test case and a test scenario? We say that a test case is an implementation of a test scenario. And you know, test scenario optimization is very much important activity in software testing. Otherwise, see, we are having limited time. We cannot run all the test cases. So we have to optimize the test cases, taking into account the time, what time is available to us. So what cost is available to us, what resources are available to us. With the stipulated amount of time, resources, and cost, we have to cover the testing process. So that's why we need to optimize the test cases. So test scenario optimization is one of the very important activities in the software testing process. So let's see a few of the issues in software testing. So major issue is error proneness and time consumption. They are the major hurdles in manual testing. If you are going for manual testing, then the error proneness and time consumption, it will take huge amount of time. So error proneness and time consumption are the major hurdles in manual testing. So we require what? Minimizing the test cases, optimizing the test cases, minimizing the test cases or the test suite or the test scenarios while maximizing the coverage. See, we should not just go on minimizing, but some of the elements are not covered, some of the statements are not covered, some of the functions are not covered, some of the methods are not covered. Then there is no point in testing that thing. So we have to do two things simultaneously. We want to reduce the test cases or minimize the test cases, simultaneously achieving maximum coverage. I mean maximum state coverage or maximum path coverage or maximum branch coverage. So simultaneously we have to do that, which is really a challenge for the test engineers. Okay. Minimizing or optimizing the test cases or the test suite while maximizing the coverage. That coverage could be statement coverage, branch coverage, or path coverage. It's really a challenge for the test engineers. So reducing the time, effort, and cost of regression testing is also a major issue. How to reduce the testing time, how to reduce the testing effort, how to reduce the testing cost during regression testing, it is also a major issue. So what are the difficulties in code-based testing? Because traditionally people are going for code-based testing. The disadvantage, you know, people have to wait till the code is over. So it may take, the development take 1 year time. So you have to wait till the coding is over. Similarly, nowadays in many cases, the source code is not available with you. You just try to develop a new system. First, what our students are doing, they are trying to download from the internet. So in the internet, you will get the applications. The source code you will not get. Then how to test it without you are having source code? You cannot go for code-based testing. Okay. So these are some of the source code is unavailable. So these are some of the drawbacks of code-based testing. That's why people nowadays, they are migrating towards what? Your model-based testing. So it is difficult to analyze all the behavior of the given system from the source code because some of the aspects are related to the design, some of the aspects are related to requirements. So if you just go for testing based on source code, we cannot test all the aspects. I have already told you inadequate in case of unavailability of source code, like from the internet you are downloading. In component-based software development, source code is not available. I will go for code-based testing. So test case generation process is delayed till coding is over. So if your program is a slow programmer, you have to wait till his coding is over, then only we can go for testing. So these are some of the problems associated with code-based testing. So what is the solution? Nowadays people are going for model-based testing. More or less you have known. All the models, they can be used to perform testing. That model could be a mathematical model. That model could be a graphical model, such as data flow diagrams, etc. That model could be a UML model, Unified Modeling Language model. So, you know, in UML 1.x, there are 9 diagrams. In UML 2.x, there are 14 diagrams. So all these 14 diagrams, that is 5 diagrams extra in UML 2.x, all those 14 diagrams, they can be used for software testing. So that is the beauty. So this is a very nice research area nowadays. People are going for that. Many papers are available. If somebody is interested, they can go for that. So let's a little bit see on the model-based testing. The testing techniques, they can be applied throughout the development process, not only during the coding phase. Starting from the requirements analysis phase till the system testing phase, integration and system testing, every phase you can apply the models for the software testing. The test cases can be available early in the development cycle. So test cases can be reviewed earlier. You need not have to wait till the code is over. Directly from the after the SRS phase is requirement analysis phase is over or design phase is over. During that you can do testing. So test cases can be available much early. Also test cases can be, those test cases can be reviewed much early. Okay, these test cases can be reviewed earlier. The generated test cases are independent of any particular implementation of design. So it's not that you have to follow a particular design. The test cases which you are generating by using the models, they are independent of any particular implementation of the design. You may go for C++, you may go for Java, you may go for Python, you may go for MATLAB, whatever that. It is independent of any particular implementation of design. The models can be processed efficiently as compared to code snippets. So whatever models, as I have told, mathematical models, graphical models such as DFD, etc., UML diagrams, etc., they can be processed more efficiently in comparison to the code snippets. So these are the advantages of model-based testing. That's why nowadays people are migrating towards model-based testing. Okay. Now we'll go to the next aspect. Little bit on the application of the meta-heuristic algorithms in software testing. I have already told you test case optimization is one of the important area in order to reduce the time, effort, and cost of software testing. In this regard, the different meta-heuristic algorithms they can be used to optimize those test cases. So several meta-heuristic algorithms. Meta-heuristic algorithms such as genetic algorithm, particle swarm optimization, ant colony optimization, cuckoo search optimization, then firefly algorithm, differential evolution, etc. They can be used for optimizing the test scenarios. You are using, say, many people are using for different purposes. Somebody using for networking, somebody using for image processing, somebody using for the social network analysis. So we are using for the software testing. They can be easily used for optimize the test cases. So for object-oriented systems, because my talk is based on this testing of object-oriented systems using meta-heuristic algorithms. So for testing object-oriented systems, I have already told you we should go for the model-based testing. So model-based testing means you can use the different UML diagrams. All the 14 UML diagrams can be used for generating test cases. So for object-oriented systems, the test scenarios, they can be generated using various UML diagrams, such as activity diagram, sequence diagram, communication diagram, state chart diagram. Each of the UML diagrams can be used for software testing, for generating test cases. In my talk, I have used two diagrams also. One is the sequence diagram, another is the activity diagram. I have used them to first generate the test cases. Then we have applied this cuckoo search algorithm to optimize the test cases. Okay, so once the test scenarios are generated by using the UML diagrams, then they can be optimized by using the meta-heuristic algorithms, maybe PSO, SU, or cuckoo search algorithms, etc. These optimized test scenarios, they will require less amount of effort and less amount of time for execution, and hence the testing time will be reduced. So in this way, we have tried to use the meta-heuristic algorithms for software test case or test scenario optimization process. Now, a little bit I want to tell you where this test case optimization it fits in. So we have to know a little bit about regression testing. Regression testing is not a specific. It is not, or it does not belong to unit testing or integration testing or system testing. Rather, it is a special dimension to testing. Many of you already have known regression testing. That means regression testing is a process in order to ensure that if any changes you have made to the system, then that changed system or that modified system, it does not, the performance of that modified system, it does not deteriorate in comparison to the original system. If you have modified any change, you should ensure that the modified program, it behaves at least as good as this previous system. So what might happen? Suppose here I have shown an example here. In my original system, there are 4 modules ABCD. Now I have added 2 modules, GH. See, modification means you can add a module, you can delete a module, you can modify a module, you can change a module. So in either case, the system should not deteriorate. So what you see, with the original programs with 4 modules, I have passed it through the original test suite T. Now I have added 2 more modules, GH. So then that means I have modified to my original program. So the same test suite may not be directly applicable to the modified program. We might have to add a few more test cases because the GH are new. These are some new functionalities. The old test cases may not be sufficient for that. We might have to add. Or if you are changing some modules, some of the test cases of T, they become obsolete, irrelevant. So we have to replace them. We have to completely drop them. Or we have to make some changes. So the objective is that whenever you are making any change to a module, then the unchanged modules should not be affected. You know, while you are writing a C program, in the first compilation, you have got the 5 errors. While you have corrected all those 5 errors, but as a side effect, you are getting another 2 errors. So then this process of ensuring that due to correction of one error, another side error is not arising, in order to check that, we follow regression testing. So regression testing is the process of testing the software in order to ensure that the changed part, it works perfectly, and the unchanged parts, they are not affected due to the changed parts or due to changes or the modifications made to some portions. For that, we might have to add some new test cases because see here GH are added, so obviously it will not be sufficient. We have to add some more like that. You please imagine if you are 10 times you are making modifications, how this original test suite will be growing. It will grow. So if you are making 100 modifications, the size of the test suite will grow. But we are having limited amount of time, effort, and resource. What to do? We have to go for test case optimization. How to remove the obsolete test cases, how to remove the redundant test cases, how to remove the irrelevant test cases. So those things, if you can do, we can only, then if we remove those test cases, we will be only left with the most important test cases. That process we call as test case optimization. Okay, so this is where test case optimization fits in during the regression testing process. There are 3 types of regression testing. One is test case selection, then test suite optimization, then test case prioritization. In test case selection, what we are doing, as I have already told you, see here test case is 100 test cases. And suppose we have modified something. So some of the test cases are already becoming obsolete. So we have to choose only the most relevant test cases. We have to select a subset of T, maybe T1 from T. How to select this subset of T1 from T? Many criteria are there. We will not discuss that. So that is one process. How to select the appropriate test cases for regression testing for the modified program. This is called as the first problem, test case selection. Then test suite minimization or optimization or reduction. Drop these obsolete test cases, redundant test cases, and your irrelevant test cases. Next approach is test case prioritization. So the test case prioritization is what? It is the process of prioritizing the test cases. What do you mean by prioritization? See, as I have already told you, suppose we are having 100 test cases here. In peak prime, we have seen 100 test cases, but we are having limited amount of time. So what we can do, we can give some weights or rank to the test cases. Then depending on availability of the time, so we can say that during only this available time, we can only execute only 70 test cases. There are total 100 test cases. So which 70 I have to run? What to do? I have to give priorities, ranks, so that the first 70 test cases will be run during the available time. Other 30 we have to forcibly skip because due to lack of time. So those 30 test cases are less important. So how to identify which are important, which are non-important? So this is a process of test case prioritization. There are several criteria, several algorithms based on which you can assign some rank, some weight to the test cases, so that, and then you arrange in decreasing order, depending on the availability of the time. the first n number of test cases you will execute, remaining test cases you will simply drop. So this process is called as test case prioritization. So in this way, I have told where the test suite minimization or optimization fits in the software testing process. Okay. So now we'll see this meta-heuristic algorithms, little bit fundamental. Many of you have already known. I will just quickly skip these things. You know, meta-heuristic means meta-heuristics are the strategies which guide the search process. What is the goal here? The goal here is to efficiently explore the search space in order to find the near optimal solution. Okay, so here the goal is to efficiently explore the search space. Why? In order to find the near optimal solutions. This is the meaning of these meta-heuristic strategies. Then what is the difference between the heuristic strategy and meta-heuristic strategy? You can see heuristics are often problem dependent. That means you have to define an heuristic for a given problem. But meta-heuristic means they are problem independent. They are not applied to a particular given problem. They can be applied to a broad range of problems. So this is the difference between heuristics and meta-heuristics. There are several classifications of meta-heuristic techniques exist, such as local search versus global search, single solution versus population-based, hybridization versus mimetic algorithms, parallel meta-heuristics, and nature-inspired meta-heuristics. I hope you know these things, but still some of them you may be beginners. I'll quickly have a look at these different types. First, let's see local search versus global search. As its name suggests, local search, these techniques find the good solutions by iteratively making changes to a single solution. And that single solution is known as the current solution or incumbent solution. That's why this is known as local search. Okay. So local search, it finds the good solutions by iteratively making the changes to a single solution. That's why this is known as local search. This single solution is called as the current or the incumbent solution. Example is the hill climbing method. You know, that is an example of local search technique. In contrast, a global search algorithm is intended to locate a global optima, not a local optima. It is intended to locate a global optima. It is suited to traversing the entire input source. Okay, so global search algorithms, they are suited to traversing the entire input source space and getting close or finding exactly the extreme of the function. Examples of global search algorithms are ant-colony optimization, evolutionary computation, particle swarm optimization, genetic algorithm, rider optimization algorithm, etc. These are all examples of global search algorithm. We'll go to the next classification. Single solution versus population-based. Single solution approaches, what do they do? They focus on modifying and improving a single candidate solution. That's why the name is single solution. So the single solution approaches, they focus on modifying and improving a single candidate solution. The single solution meta-heuristics, they include what? What are the examples? Now, single solution meta-heuristic algorithms include simulated annealing, iterated local search, variable neighborhood search, and guided local search, etc. So in contrast, let's see what do the population-based approaches they do. The population-based approaches, they maintain and improve the multiple candidate solutions. Okay. In populated-based approaches, they maintain and improve the multiple candidate solutions, very often using the population characteristics to guide the search process. The examples are evolutionary computation, genetic algorithms, PSO, SEO, cuckoo search algorithm, Firefly algorithm, etc. They are coming under population-based approaches. The third classification is hybridization and the mimetic algorithms. As you know, hybrid meta-heuristic means what? Hybrid meta-heuristic means it is one technique that combines a meta-heuristic with other optimization approaches. For example, algorithms from mathematical programming, constraint programming, and machine learning, etc. You can take different algorithms and you can combine. Both the components of a hybrid meta-heuristic may run on concurrently and exchange information to guide the search process. But what is mimetic algorithms? Mimetic algorithms, they represent the synergy of evolutionary or any population-based approach. Okay. The mimetic algorithms, they represent what? They represent the synergy of the evolutionary or population-based approach with separate individual learning. So here the learning process is individual with separate individual learning or local improvement procedures for the problem search. An example is so an example of mimetic algorithms is as follows. A local search algorithm, instead of the basic mutation operator as you are doing in evolution algorithm, this is a very good example of mimetic algorithm. Okay, an example of mimetic algorithm is what? Is the use of a local search algorithm instead of a basic mutation operator in the evolutionary algorithms. Okay, the fourth classification is parallel meta-heuristics. A parallel meta-heuristic is one that uses the techniques of parallel programming. Why? To run multiple meta-heuristic searches parallelly, in parallel. So these may range from simple distributed schemes to concurrent search runs that interact to improve the overall solution. So here you can run those algorithms parallelly. They can be run in a distributed manner or they can run also concurrently. The nature-inspired meta-heuristic. So many recent meta-heuristics, particularly the evolutionary computation-based algorithms, that are inspired by natural systems. So here the nature acts as a source of concepts, mechanisms, and principles for designing of the artificial computing systems in order to deal with the complex computational problems. You have known many examples of nature-inspired meta-heuristics. The examples are like simulated algorithm, evolution algorithms, ant colony optimization, particle swarm optimization, then your cuckoo search algorithm, Firefly algorithm, they are also coming under this nature-inspired meta-heuristics because they are inspired by the natural systems. So in our work, we will discuss about the genetic algorithm and cuckoo search algorithm, how they can be applied for test case optimization. So with this, now let's go for this motivation, why the people are doing generating the test cases and optimizing them using the different meta-heuristic algorithms. So design models such as UML diagrams, they are very much suitable and efficient for test case or test scenario generation than the source codes. I have already told you why UML diagrams are better for generating test cases than the source code. So people are trying to use UML diagrams for generating the source codes. The test case generation from UML diagrams is much more advantageous since it allows the test plan which can be carried out in parallel with the development cycle. Parallelly, you do the requirement analysis, simultaneously design the test cases from the requirements. Do the design, simultaneously from the design documents, generate the test cases. So that's why people are using the design documents to generate test cases which can run parallelly with this test development or with the software development life cycle. The test cases generated from the combinational model will have more coverage and more fault detecting capability as compared to test case generation using single individual models. What does it mean? Previously, people are using only one diagram, either sequence diagram, activity diagram, state diagram, etc. But then people have found out if we can combine two diagrams, say sequence diagram and activity diagram, then we can get the advantage of detecting both the types of faults. Say activity diagram normally it is used to detect activity related faults, synchronization related faults, but the sequence diagram is used to generate this faults due to message passing. So if we can combine these two modules, we can detect both the activity related faults as well as message related faults. That is the beauty of combining these two different models. This is known as test case generation from combination of models. So this I have done in my approach. I have combined activity diagram and sequence diagram, then generated the test cases, then applied cuckoo search to optimize them. So test case optimization technique it is required to reduce the testing time. This I have already told you. So the objective of this work is to develop some approach for generating the test scenarios using UML behavioral diagrams. Here I have used sequence diagram and activity diagram. Then we'll try to optimize the test scenarios which are generated by the UML behavioral diagrams using meta-heuristic techniques such as genetic algorithm and cuckoo search algorithms. So there are several literatures available on test case generation, test case optimization, and test case prioritization. We are running out of time, but those who want to do research on this, I have given some works. You can go in that. Let us directly go to our work because we are running out of time. So the slides are there related to this test case generation, test case optimization, and test case prioritization. Those who are interested, they may look at these slides, and so many new works are also coming on every day. You can look at them. Like Sharma et al., they have used sequence diagram to generate the test cases. Kundu et al., they have used activity diagram. Samuel et al., they have used communication diagram to generate test cases. Similarly, on test case optimization, you see many works are available. Like Singhal et al., they have used genetic algorithms for optimizing the test cases. Martin et al., they have used the mutants concepts. They have used the concept of mutation process to generate the test case, optimize the test cases. Kumar and Muthu Kumar Avel, they have used improved cuckoo search algorithm to optimize the test cases. Lakshminarayan et al., they have used hybrid cuckoo search with bee colony algorithm to optimize the test cases like this. Many more works are available. You can look at them. Similarly, test case prioritization, these are the works available on test case prioritization. And this is not related to today's talk, so we'll skip these things, but this is a very good research area people are doing nowadays. If anybody is interested, he may or she may continue in this area. So we'll skip these things because we are running out of time. I'll directly, okay, this is the summary of this work, available work on test case prioritization. We'll not go to that, we'll directly come to our work. So since I have already told you, we are using cuckoo search algorithm for optimizing the test cases. Let's know a little bit of fundamental of cuckoo search algorithm. I know many of you are already, you have known ant colony optimization, cuckoo search algorithm, and this particle swarm optimization, etc. But just in order to link the what contents, let's take 5 minutes to explain the concept of cuckoo search algorithm. Then we'll apply for software test case optimization. You know, cuckoo search algorithm was inspired by the obligate brood parasitism of some cuckoo species by laying their eggs where? In the nest of other host birds. Here the host bird can be a crow, because you know normally these cuckoo, they lay their eggs in this nest of the crows. So so this technique was inspired by that phenomenon. It was inspired by the obligate brood parasitism of some cuckoo species by laying their eggs in the nest of other host birds. Some host birds can engage direct conflict with the intruding cuckoos. That may also happen. Some host birds, they can engage direct conflict with the intruding cuckoos. Cuckoo search is based on normally 3 rules. First is that each cuckoo lays, we'll assume that each cuckoo lays 1 egg at a time, and she dumps its egg in a randomly chosen nest. Okay, she may dump its egg in a randomly chosen nest, maybe in the nest of a crow. The best nests with the high quality of eggs will carry over to the next generation, and the remaining eggs will be simply destroyed. Now, the number of available host nests is fixed. So this is also a rule that we have to accept, we have to assume. The number of available host nests is fixed, and the eggs laid by a cuckoo, they are discovered by the host bird. Okay, if I have already told you only 1 egg can be laid by a cuckoo. So the number of available host nests is fixed, and the egg laid by a cuckoo is discovered by the host bird, maybe by a crow, with a probability P, and the value of that probability, it lies in the range 0 to 1. So with these 3 rules, let's move towards this little bit fundamental of the algorithm of or the flowchart of the cuckoo search algorithm. Cuckoo search algorithm, it works like this. Many of you have already known. So it's not start. It should be start. There's a typing mistake. This will start. Then initialize a random population of n hosts. So let's assume that there are n hosts. Initialize a random population of the n hosts. Then get a cuckoo, say ith cuckoo, randomly by Lebesgue. You know, Lebesgue is a function, and this is based on this Lebesgue probability function, isn't it? So it's a distribution function. Lebesgue distribution is a probability distribution that is heavy-tailed, And there are some equations. Those who want, they may see this paper on cuckoo sorts. You can see what is what equation, what distribution is used for Levi-Split. It uses Levi's distribution. Okay, it's a what you can say Levi distribution. It's a probability distribution that is heavy-tailed. Will not go into detail. I hope you know. Those who have forgotten can look at this available literature on cuckoo sorts, any book or any paper. You can see the equation for Levi-Split. Get a cuckoo I randomly by Levi-Split and then evaluate its fitness Fi. So for this fitness function, there's the equation you have to use that. For our test case optimization, we have also used a fitness function that I will show later on. Then choose a nest among n hosts. Okay. So then what you have to choose a nest among the n hosts randomly. Say j with the fitness value fj. Then you compare fj with fi. If fj is less than or equal to fi, if it is true, then you come to here, replace j by the new solution. If fj is not less than or equal to fi, then let j as continue as the solution. Then we have to abandon a fraction of worstness. I have already told you only these quality things will keep, others will be, they have to be what discarded. Abandon a fraction of worstness and builds a new one at the solution at the new solutions using again this Levi-Split. Then keep the best solution or the nests. Then you can use a threshold value because you have to use some stopping criteria. If this t is less than maximum iteration, you can take some threshold value. If threshold value is less than maximum iteration, then you have to again repeat the process. Again, go to that second step. Get a cuckoo I randomly by Levi-Split and evaluate its fitness function Fi. If this is if it is yes, so if it is not, that means already the stopping criteria is satisfied. If it is no, then you have to rank. Then you have to rank the solution and find the best solutions. Then the process comes to an end. So this is how the very fundamental cuckoo search algorithm works. Instead of whether you are using to networking or email processing or software engineering, this is the basic cuckoo search algorithm. Whatever I have explained, this thing I have put in the form of a algorithm so that you can easily implement it, and you can easily implement in C, Java or MATLAB. So same thing we have explained it here. Now we'll go to the actual work. How test scenarios can be optimized using these behavioral diagrams such as sequence diagram and activity diagram, and then how first we are generating the test cases using this sequence diagram and what activity diagram. This is applicable. I have taken an object-oriented system. So for an object-oriented system, we have first constructed the sequence diagram and activity diagram. Then we have used the cuckoo search algorithm for optimizing the test scenarios. Let's quickly explain how does it work. I have already told you I am taking two diagrams because if I will combine two diagrams, I will give the mixed advantage. Both the types of faults I can detect. So that's why instead of taking one diagram, I have taken a combination of activity diagram and sequence diagram as input. Then from these two diagrams, I have generated an intermediate diagram, an intermediate graph I call as ASG. A for activity, S for sequence, then G for graph. So from the activity diagram and sequence diagram, we have constructed this ASG activity sequence graph. Then on this activity sequence graph, I have applied the traversal algorithm. You can apply depth first search algorithm or you can apply breadth first search algorithm in order to generate the test cases, okay, or test scenarios. Now, then generate test scenarios from ASG by applying either DFS or BFS. So now you are generating a huge number of test cases. Our objective is to minimize or optimize. How to minimize or optimize? To minimize the test suite or to optimize the test suite, we have used cuckoo search algorithm. Then after these test cases are generated, we have, after these are minimized, then we have tried to prioritize by using some weights. We have ranked them. We have prioritized the test scenarios. So the final output is optimized and prioritized test scenario. This will be first optimized test scenarios, then we have ranked so that when considering suppose again time is constraint, since we have ranked, the first rank test case or test scenario will be executed first, then the second rank test scenario will be executed like that. So the final output is an optimized prioritized test scenarios. Okay, so the final output is this set of prioritized, optimized prioritized test scenarios. Okay, this is how our approach it works. So the steps I have already told you. First, we are constructing the activity and sequence diagrams for the given problem. Then we are constructing an intermediate graph named as activity sequence graph from these activity diagram and sequence diagram. Then we are generating the test scenarios from this intermediate graph, that is activity sequence graph, using traversal algorithms such as BFS or DFS. We have used DFS in fact in our approach. Then we have optimized the test suite or the test scenarios using cuckoo search algorithm. One step I have missed, that is then we have prioritized the test scenarios. We have prioritized the optimized test scenarios. Okay, these are the steps we have done in our work. Now I will try to explain the approach by taking a case study. We have taken several case studies. The first case study will take, that is the hospital management system. You know, a hospital management system, a huge number of requirements are there, both functional and non-functional. But for our implementation point of view, we have considered very few requirements. So our functional requirements are as follows. The hospital management system is a software application which automates the process of patient registration, one activity, visitor interaction, fixing appointment with the medical representatives, revert to the phone queries, etc. The patient registration, this activity includes checking the schedule of all doctors, taking appointment of doctor, admission of the patient to ward, undergo operation, conduct pathological test, updating the required test and reports, and some other activities also we have considered. So this is the brief description of a hospital management system we have considered. So now let's go back to our approach. What we will do? First, we will construct the activity diagram and sequence diagram. Then we will draw the activity sequence graph and intermediate graph from these two diagrams. Then we will traverse that diagram to generate the test cases. Finally, then we will optimize this using cuckoo search algorithm. And finally, we will prioritize the test cases or the test scenarios. Okay. So now let's see what is the first step. Construct the activity diagram. I hope many of you have already known activity diagram. Due to lack of time, I am not able to take all those how to generate this. But the slides I have included, these things are very nicely explained in Professor Rajimol's book. Those who have not known how to construct the UML diagrams, please have a look into this, because I could have covered here. Due to lack of time, I am skipping this thing. But I have already put the slides in this in this material. Okay, so like this activity diagram, it was not present earlier. It was possibly based on the event diagram of Odell. Okay, and why this is used? Activity diagram is very often used to represent the processing steps in a single or a group of use cases. So your system may consist of a number of use cases. Now the activity diagram will be used to represent the processing steps in a single use case or a group of use cases. Okay. So please remember, the activities here may not directly correspond to the methods that you have used in your system. Then what is an activity? An activity is a state with an internal action and has some one or more outgoing transitions. So an activity normally it is a state which has an internal action and one or more outgoing transitions. For example, if you are doing the order processing system, so fill the order, it is an activity. Dispatch the order, another activity. Process order, another activity. So these are the activities. Then you will see how these activities, how flow occurs in the, how flow occurs among the activities. Similarity almost exists with a flowchart. Very often is asked in the examination, what is the difference between activity diagram and flowchart? So some of the differences I have shown here, like activity diagram can represent the parallel activity and the synchronization concepts, but your flowchart cannot represent the, see, if two activities are parallelly they are occurring, your flowchart cannot show. Similarly, the synchronization aspects, they cannot be represented by flowchart. Another important concept is swim lane. So, which is a unique feature of activity diagram. What do you mean by swim lane? Swim lane, they can be used to group different activities based on who is performing them. which person or which agent is performing some activities, then you can group them. This is we call a swim lanes. Swim lanes is available in only in activity diagrams. You can represent swim lanes only in activity diagrams, not in flowchart. Okay. So I have shown some of the activity diagrams here. So, and when you will draw the activity diagram, in which page? Normally it is employed in the business process modeling. Normally activity diagram is employed in the process of business. Okay. Normally the activity diagram is employed in business process modeling. It spans one or more use cases. So normally we use in the requirement analysis phase. Okay. Activity diagram is carried out during the requirement analysis and specification phase. This is very much useful in developing the interaction diagrams and test cases. So, you know, two interaction diagrams are there, sequence diagram and communication diagram. So in order to develop the interaction diagrams, you will feel easy. It will be much more easier if you can use first the active diagram. So if you can draw first the activity diagram, it will be very much easier for you to draw the interaction diagram such as sequence diagram and your communication diagram. So some examples I have shown here. This is an activity diagram for an order processing system. You can see the different activities. So that the receive order is an activity, then fill order, ship order, then see these are fork and join. I have told you synchronization aspects. So this is synchronization point. This you can say fork, the activity went into two parts. And this is join. See, two activities are joined at this point, then one. So this is join. This is decision. These numbers are decision, whether you want to accept the order or reject the order. Okay, so anyway, we are running out of time, but the diagrams I have shown here some examples for your better understanding. Details are there in Rajimov's book, you can look at. Similarly, another activity diagram I have given for the student admission process at NIT Rourkela, IIT Rourkela, or IIT Kharagpur, etc. See, these are the different places. These are swim lanes. Say, hostel office is performing the activities, alert hostel, receive fees, alert room, etc. Hospital, you are performing these activities, create hospital record, conduct medical examination. So these are all we call swim lanes. So swim lanes are only available in activity diagrams, not in the flow charts. Still another example is there for order processing. These are many examples on activity diagram you can do yourself. It will not so these are some uses and abuses of activity diagrams. These are easy things you please read yourself. We will not discuss that means when to draw activity diagram, when you should not draw activity diagram, those things are explained. You can please go through yourself. If you will not mind, I have given a small homework for to draw the activity diagram for an order processing system. The detailed problem is given. Those who are interested may draw the activity diagram for this, for your practice of how activity diagrams can be drawn. So next, I'm coming to my work. So now I have to draw the activity diagram for my system, that is hospital management system. See, so many activities are there, and I have drawn these activity diagram, shown the activities are this. So these what rounded corner rectangles, they represent the activities. This red one is the start activity. This red bullet, so covered by another circle. This is the terminal or the end node. All those rectangles with rounded corners, they are these various activities, and you can see these are the these bars. They represent the synchronization points. I mean, here this is the fork point. Here this is the join. This is the fork point. Here this is join. Like this, the bars they represent the forks and joins are respectively at the different points. So this is how we have drawn this activity diagram for the hospital management system. See, different activities are refer to phone queries, give appointment to medical representative, visitor interaction, patient registration, like this, so many things we have added. So in this way, you can draw the activity diagram for a given system. Now we have drawn the activity diagram for the hospital management system. How we have drawn it? Several tools are available. We have drawn it using rational rows or that RSA, Rational Software Architect. Besides that, eDraw, Magic Draw, so many other tools are available. You can draw these all the UML diagrams. Okay. Now we'll go to the next one, construction of sequence diagram. So since this is a little bit important for you, again some basic slides I have put on sequence diagrams. Those who are interested may go through this because due to lack of time I'm skipping. So what do the sequence diagram does? The sequence diagram, it captures how the different objects interact with each other. Okay. What are the different objects in an use case? So how the different objects they interact with each other in order to realize some behavior. That's why the system, the sequence diagram is drawn. So, okay. ST, the sequence diagram captures how the different objects interact with each other in order to realize some behavior. Okay. The sequence diagram captures how the different objects interact with each other in order to realize some behavior or use case execution. The sequence diagram, it emphasizes on the time ordering of the messages, how the messages will be sent. What is the ordering of the messages? The sequence diagram emphasizes on that fact. Okay. It can model simple sequential flow. It can also model branching aspects. It can also model iterations. It can also model recursion. It can also model concurrence aspects. So how to model sequential, branching, iteration, recursion, and concurrence aspects, I have shown in the next slides. But these are easy things. I'm skipping these things. Those who are interested may go on the slides as well as on Rajimol's book, how to construct a sequence diagram. Okay. So, but the question is, how many sequence diagrams you will draw? See, your program, your software or your system consists of several use cases. What do you mean by use case? High-level functional requirements. So your system consists of several high-level functional requirements. So how many sequence diagrams you have to draw? For every use case, you have to draw one sequence diagram. For example, suppose your library information system. What are the use cases here? What are the high-level functional requirements? Issue book, return book, source book, compute file, etc. So these are the high-level functional requirements. These are the use cases. So for every use case, draw a sequence diagram. Okay, that is the rule. So like this is a simple sequence diagram we have used for maybe borrow. For borrowing a book, we have drawn a simple sequence diagram. Here the rectangle boxes, they represent the objects. These are the objects. One object is a book, another is a member, another is a book also. So these dotted lines, they represent the lifelines. The squares or the rectangles on the dotted line, they represent the active, when this object becomes active. So that is represented by these rectangles. The arrows represent the message passing, how the message flows from one object to another object, that is represented by the arrows. So these are simple things how to draw the sequence diagrams. This is not the place to teach how sequence diagrams can be drawn, but I have given sufficient hints how to draw. I request you please practice those things. If any doubt will be there towards the end of the class, you can ask me. Okay. So these fundamental things I have already shown you, like sequence diagram show the interaction among objects in a two-dimensional chart, and the objects are shown as the boxes at the top. I have already told you these boxes, they represent the objects. Okay. If an object is created during the execution, then it is shown at appropriate place in the timeline. You see, we have shown it. It is created here, so it is shown in the appropriate place in the timeline. Okay. If object is created during execution, then it is shown at appropriate place in timeline, and the object existence is shown as dashed lines, which is called as lifeline. So these things are fundamental things. Object activeness is shown as a rectangular lifeline. These things already we have discussed. Okay, this is already we have shown. The fundamental things, and the messages are shown as arrows. Each message is labeled with the corresponding message name. What is the message name? You write it maybe alongside the arrow. Okay, each message it can be labeled with some control information. Also, you can put like two types of control information you can represent. If any condition, say whether accepted or rejected, those type of conditions you can represent. Iteration, if you want that a message should be sent for 10 times or n number of times, that can be, so condition can be represented with the square bracket, iteration can be represented with the star, etc. So these are all the fundamentals of sequence diagrams. See, here I have shown these different, what you can see, these different aspects of the sequence diagrams. We are running out of time. I am skipping this thing. So if anybody is interested on this sequence diagram, those are not thorough, please go through Rajimol's book and these additional slides. We'll see. One difference I want to say that in UML2, it uses a new notation called interaction frames to support this. So in order to support iteration maker, condition, self-delegation, loops and conditionals, so better facilities are there in UML2. In UML1, these are not properly defined. The proper provisions are not there. in UML 2.0 onwards, some better facilities are provided to represent these aspects. So UML 2 uses a new notation called interaction frames to support these features. Okay, we'll skip those things. We're running out of time, but you may read yourself. So now this is my, as I have already told you, you have to draw the sequence diagram for each use case. So if there are 10 use cases, you have to draw 10 sequence diagrams. So in my hospital management system, there was one use case called as give medicine or prescribe medicine to the patient. This is the use case. So this is the sequence diagram for this give medicine to patient use case. The patient, doctor, operation, test, these are the objects, these are the lifelines or the timelines, these boxes. So when this object becomes active, the arrows represent what the messages, and dotted arrows represent this what these written messages. You can see the messages are numbered so that you can see, even if you may not number because this hierarchy can say which message is sent first, which is next. But several tools they allow to give numbering in order to know the ordering of the messages. So in this way, you can draw the sequence diagram. This is the sequence diagram for the hospital management system. Okay. So now the second step of our algorithm, combine the, we have to construct an intermediate graph called as activity sequence graph from this activity diagram, sequence diagram. How to do? So for this, first draw the nodes of the activity diagram. Then you see you have to merge two diagrams. You have to merge two diagrams, the activity diagram and the sequence diagram. At the time of merging, the different activities and the different messages, they are closely observed. If any message in the sequence diagram is related, is linked to any activity of the activity diagram, then what happens? Then those two things are merged. That means the corresponding activity and the message, the concerned activity and the message, they are merged at a single node. And in this way, we construct the activity sequence graph. I am repeating again. We first draw the activity diagram, then the sequence diagram, then we merge the two diagrams to draw the intermediate graph, activity sequence graph. How do we merge? We first look at the what the different activities and the messages in the activity diagram and sequence diagram. If any message in the sequence diagram is related, it is linked to any of the activity in the activity diagram, then those two activities and messages, they are merged as a single node in the intermediate graph, activity sequence graph. So you can look at, so now you have seen, this is my final activity diagram. Where is, this is my final activity diagram. Yes, this is my activity diagram. So many nodes are there. And you can see, okay, then there are so many messages in my message sequence diagram. You can see these are so many messages, perform, takeoff, return, etc. like this. So many messages in this sequence diagram I want to combine. So by merging these two diagrams, this is the combined diagram. We have this is the intermediate diagram we have called as ASC, activity sequence graph. You see now, since it will a bigger name, what I have done, this I have used some symbols like AD1 and AD2. What are they? AD1 is the start node. What is AD2? Revert to phone queries. You can have seen in my this, there is a revert to phone queries option. Yes, this one is revert to phone query. I have given as the node name as AD2 so that the graph can be drawn in a compactable way. So like this, so what are the notations we have used in the activity diagram? I have given you a table so you can easily understand this. Okay, AD2, what is AD2? It is this revert to phone queries. Like this, all the node names have been explained in this table. Now you see, I am giving particular one example. I have told when any message in the sequence diagram is related to any activity of the activity diagram, then we do not construct two nodes. We merge them into a single node. You can look at. See, in this, there is AD12, we can see. AD12 results, it represents undergo operation. So, AD12 represents undergo operation. You can see in the message diagram, there is a one, see, get operate. So, undergo operation activity is related with what? Get operate. So this activity undergo operation and the message get operate, they are linked, they are related. So I have to merge this activity and this message into one. That I have done here. You can see here AD12 and sequence 12. Sequence is message number 12. So activity 12 and message 12, now they have merged together into one, because because this you can see undergo operation and what is undergo operation and this activity get operate, they are linked, they are related. So we have merged AD12, that is the node of activity diagram, node 12 of activity diagram, and message 12 of a sequence diagram. They have merged into one diagram. Similarly, you can see other nodes are there. AD12, sequence 13, AD46, sequence 6, and you can see other somewhere else like AD34, sequence 8. So these are related, so that's why they have merged into one, and we have drawn the intermediate graph, activity sequence graph. We'll take few minutes to wind up. These are the node details of the activity sequence graph. Then we have to generate the test scenarios from the activity sequence graph using a traversal algorithm. Here we have used depth first search. We have applied depth first search for traversing on the SG, and we have generated the test scenarios. Here test scenarios are nothing but the sequences of the nodes and edges. They will become the test scenarios here. These test scenarios are generated from SG by applying depth first search. For this hospital management system, this case study, 61 test cases or test scenario are generated by traversing on the SG. A sample screenshot I have shown. So this is only part, not all the 61. You can see a portion of the screenshot has been given. And here you can see the test cases are nothing but the nodes and the sequence of the nodes. The sequence of the nodes are shown here. For easy thing, we have replaced AD, we have AD and ST, those terms we have not put in the implementation. So here they simply they represent the number of the node number of the ASG. So finally the test scenario means sequence of the nodes, those are present in the activity sequence graph. Okay, these are the test scenarios. After that, we have optimized the test scenarios by using cuckoo search algorithm. The generated test scenario are used as input for test scenario optimization process. We have implemented, I have already told in the cuckoo search algorithm, we have to use a fitness function. We have implemented the following variation of cuckoo search algorithm for test scenario optimization. We have calculated the fitness score of each test scenario of each test scenario. Mathematically, the fitness score of a test scenario is defined as follows. The fitness score is equal to WP into NP plus WC into NC. This we have defined. WP, it represents weight of each path or weight of the path coverage. NP represents the normalized values. We want to normalize. NP represents the normalized value of path coverage. WC represents the weight of the value of that test scenario, and NC represents the normalized credit value of test scenario. Like this, we have defined depending upon our problem. So we have defined the fitness score. Then we have found out what are the redundant test cases, and then generate the optimal test cases. Now the process is terminated when all nodes are covered. So when all the nodes of the activity sequence graph are covered, then the process is terminated. Okay. So these are the generated test scenarios for hospital management system case study from ASG. I have already told you 61 test cases we have generated. Here are these test scenarios. Here test scenario means sequence of the nodes of the activity sequence graph. Then we have to find the optimal test suite by eliminating the redundant test scenarios. What are the redundant test scenarios you have removed so that we can optimize the test scenarios? We have maintained a list for all the visited nodes in the graph and the set of optimized test scenarios. Then the test scenarios, they are traversed one by one to check the redundancy. If the correct test scenario, if the current test scenarios cover any new node, then what happens? Then that test scenario added to the set of the optimized test scenarios, keeping the best nest according to the cuckoo search process. Else it is abandoned, it is discarded. This is according to the abandoned step of the cuckoo search algorithm. So now finally we have to terminate the process when all the nodes of the activity sequence graph are covered. After each iteration, all the nodes of the graph are verified in order to see whether the node is visited or not. That is to check whether the stopping criteria or the termination criteria has been met or not. If all the nodes are visited, then the process is completed at that step. Otherwise, the process again continues with the next test scenario. This is how we have used the cuckoo search algorithm to optimize the test scenarios. You can see this is the optimized set of the test scenarios. From 61 test cases, we have now reduced to 16. A good achievement in the reduction process. The fitness scores of each test scenario we have shown in the right-hand column. Of course, when there is same value, we arbitrarily give the weight. That means we arbitrarily rank. So the first 4 are same. So anyone you can take as 1. So rank all of them. Who are same, you can give actually same rank to them, or you can just give rank arbitrarily. Randomly you can rank them. Okay. So this is the comparison results. We have compared our result with another approach, that is using the genetic algorithm, and another artificial networking based algorithm, IOA, intelligent optimization agent. We have shown that the total number of test cases, reduced number of test cases in IOA, reduced number of test cases using GA, and reduced number of test cases using cuckoo search algorithm. What is the percentage of reduction? How much time it has taken like this? We have taken 10 test cases. The data sets where we have taken, we have given the reference, and we have seen by using cuckoo search algorithm, we have achieved a significant reduction rate here. Okay, this is the advantage of using cuckoo search. It works, and we have found our algorithm performs better than these works. We will skip these things. Okay, finally, we have compared our with the 2 other works, Nagar-ETL and Answer-ETL, and you can see in our approach performs better reduction rate. That means if here in HMS 61 test cases without applying optimization technique, and with applying cuckoo search algorithm, it is reduced to 16. Whereas in case of Nagar-ETL, it is reduced to 33, and in case of Answer-ETL, it is reduced to 25. So in this, you can see that the cuckoo search algorithm gives better result or better rate of reduction, and it achieves better optimized test suite. Okay, cuckoo search algorithm it produces a better optimized test suite. Okay, this the comparison also we have shown graphical here. So finally, I want to say that we have generated some test scenarios using UML diagrams first. Then we have optimized them using cuckoo search algorithm. Then we have implemented these algorithms. We have compared with some other state-of-the-art techniques and found that using cuckoo search for test case optimization or test suite operation gives better results. This we have already seen. We have compared also with another METASOFT algorithm, that is GA, and the cuckoo search algorithm gives better results in comparison to GA. We will look at some of the future research directions. We have here used only one technique, cuckoo search algorithm. You can combine. You can hybridize different optimization technique. So it might be intelligent optimization agent with cuckoo search, or GA with cuckoo search combined, or GA with PSO, or GA with uncollinear optimization, like that. So hybrid techniques may give better result. We have considered only the functional aspects here for this generating the test cases. You can also consider the non-functional aspects such as usability, testing, usability, reliability, security, etc. You can consider them while designing the test cases, while generating test cases. Similarly, we have considered only 2 diagrams, activity diagram, sequence diagram. There are other 12 diagrams. You can use other diagrams such as use case diagram, class diagram, etc. For generating the test cases. Then you can optimize them. So these are some of the future research directions. You can continue with this. These are the references. Thank you very much for your patientful hearing. Now we'll take up some questions. So sorry for taking few minutes more. Now it is open for discussion. Any question, any comment, any suggestion, I will welcome.
Anyone having any questions? Sir, I have a question.
Yes.
Myself, Dr. Shabani.
Yes.
Sir, I have a question about the way you have divided the classification of meta-heuristic system you have classified. What is the criteria? What is the parameter on which you have divided that classification? You have made that classification.
I have told na. Let's go back to quickly that one. See, first criteria is like this. See, I have not classified. This is available in the literature. You can also look at the internet. You can find out, or any book or papers. First one, based on the sorts. whether you are going for a local search or a global search. Then another classification based on this, what, a single solution or a population of the solutions. Third one based on the whether you are using any hybrid two techniques or memetic. Parallel, where you can run concurrently or parallelly the meta-heuristic algorithms. And nature inspired, you know, which are inspired by the nature. So like SEO, CSO, and PSO, all are nature-based, nature-inspired meta-heuristics. It's a very simple thing, just look at, and the examples I have shown. It is also possible that one particular technique may come under multiple number of classifications, because the classification is different. So one technique may come under different categories also. That is also possible. So one may not.
But
Yes, please.
If I want to use any one of the technique in my research, then
Yes.
what will be the preferable one? That means how I will be choosing the best technique of meta-heuristic out of all this 5 different types of classification. Which one will be more suitable? That is what I'm asking.
Okay. See,
Then how
suppose, let's say local and global. You know, local search only to find the solutions by iteratively making changes to a single solution. But in global, it is used to locate the global optima. So obviously, I should go for a global search algorithm. Why should I go for, if I am having a good number of global search algorithms, why I should go for a local search algorithm? Okay, this is, so see, one category cannot, or one technique cannot come under both local and global. Either it will local and global. It can be local and single. Similarly, it can be global versus population, or it's a global and nature inspired. But when versus is there, any technique will fall under one. You have to know the advantages of both. What is the advantage of local search and what is the advantage of global search? Based on your requirement, you have to decide, you have to go for local search or global search. If you are just searching this by iteratively making changes to a single solution, obviously you will go for only what? You will go for this local search. But if you require to locate the global optima, you should not go for local search technique like hill climbing. You should go for global search algorithms such as uncolonial optimization, particle swarm optimization, etc. Depends upon the nature of the problem. So my recommendation will be, first you clearly understand all these 5 classifications, their advantages, their disadvantages, their assumptions. Based on that, we have to see. Now, based on that, you have to see your problem will be better suitable for which algorithm. And but when you go to nature inspired, then everything is there, SEO, PSO, etc. For each one algorithm, we have to know this, what their advantage, and not only that, it is limited. Every day some new techniques are coming, and each algorithm has specific advantages and disadvantages. In the worst case, what you can do, you can try with implementing 2 algorithms. In which case you are getting better result, that you have to go. This is so experimental method, hit and trial method you have to try, and you have to know these advantages, disadvantages. Otherwise, it is there is no such good general guideline to when to go for this one. So like SDLC method, there are clear-cut rules when you should go for iterative waterfall model, when you should go for spiral model, when you should go for RAD model, when you should go for agile model, etc. But here I do not know. The meta-heuristic technique specialist, they might have known. But what I know that we should know the advantages and disadvantages of what each one, the constraints, the assumptions. Based on that, we will analyze our system, what is our requirement, then only we will choose the appropriate one. This is what, with the little knowledge, I can say from my side.
Thank you, sir.
Yes, if any more questions will be.
Hello, sir.
Yes, please.
Yes, sir. This is Dr. Sir Chaudhary. I have a question. Actually, sir, can you show the slide number 37?
37.
Yes.
Yes.
Yes, sir. Yes, sir. Sir, here you have iterated the algorithm by the maximum iteration, max underscore iteration.
Yes.
So yes, obviously we have to choose this value. So
Yes.
My question is it experimental to choose the max iteration, or is there any provision to find out the optimal value of this max iteration?
Sir, this is a stopping criteria.
Yes.
So if earlier you say that I will consider 100 iterations, of course, number of iterations more, you will get better result. But there is some saturation point, beyond which if you will still take more values, you will not get better result. So So obviously this is an experimental thing. By experimental thing you can know. Otherwise you will ask why you have taken 50 at the maximum iteration, why not 70? So you should get it by experimentally, I believe.
Okay.
But there will be a certain point after that, even if you increase the number of iterations, you will not get better. It will stagnate there. It will
Yes,
stagnate there.
Yes, that's why I'm asking if we could find out the saturation point by using some other techniques or something, or we have to go to the experimental.
Yes,
Thank you, sir, for your nice presentation.
Thank you, sir.
Yes.
Now, you have thanks a lot on behalf of the organizing team, METASOFT 2022. I thank you.
Okay,
One
thank you.
important announcement I have to do for all the participants. The keynote talk, which was scheduled to be held at 3 p.m. by Professor Swagatam Das, that is shifted to 5 p.m. So all please join for the keynote talk at 5 p.m. That is some deviation that we have done. Thank you, sir. Anybody having any, if they want to communicate, they can communicate our Professor Dr. Durga Prasad Mohapatra, sir, in NIT Rourkela. Those who are doing PhD in this area, they can communicate. Here are our participants from various reputed university, KIT University, VIT,
Yes.
Guru Ghasidas University, from inside India, also from outside India, from South Korea, some participants are there. So thank you all. Thank you all the participants. Our
The slides I will send to you.
Our presentation that will start at 11.
So I will send the slides to you. You can circulate among the participants. Okay, I will send the slides to you. If they require, you can circulate among themselves. Okay.
Yes, sir. Kindly send the slides. If any participant required, then only circulate. Thank you.
Okay, thank you very much for giving an opportunity to address to the audience. And thank you very much, the audience, for sitting for more than 1 hour. And thank you very much for your patience. Thank you very much. We'll end the session now. Thank you very much.